How's it going?
Okay, how are you?
Not bad. I understand you're on your way north again.
Yeah, I'm leaving tomorrow morning. Yep, I'll be there for probably about a week, depending on what we have. But I'm planning on no more than a week. We'll see.
Well, good. I'm happy to hear that. That's a long drive though.
You gotta if you look at this in the realm of reality. I mean, 9 to 5 is a work day, right? That's how long it takes me to get down there, 1 extra hour. So I get there usually, 9 to 6, 7 o'clock. I'm done. There's no difference in working all day. And to
Right.
get to see the beautiful scenery, it's pretty. All the way down is beautiful
I,
down there
I,
through the mountains.
I tell you, a change of scenery is good for the soul.
Yep,
That's my
it
feeling.
is. I agree. Okay, what you want to do here today?
Well, I thought, we had last time we had one of these Zoom calls. We discussed boilerplex and some of the uh, uh, kind of the history of of what it is you did to develop the hydroplex, and today I thought we talk about briefly about a couple of objections we've gotten in the past in recently
Mhm.
and repeatedly actually, and then just maybe spend a little time on boilerplex if we have any time left over.
Yeah, we can do anything you want. What I was thinking when you had mentioned that the fellow was saying, "Well, I've heard that kind of stuff before, and everybody does it." I'll tell you, he is totally wrong. And what I wanted to bring to your attention that might be of value to you is it's all in writing for us. It's on the new flyers, whatever the hell they call them.
Brochure.
Uh, yeah, if you were to read or your customer would have, when he says, well, everybody does that or somebody does it or whatever, say, you're wrong. Let me show you what we do. And you got that whole list of stuff that we do on the back of the brochure. And I'll go just a couple of them with you. For example, we have a scale controller, no scale with what we do. You have a core view which measures if you have any problems with the piping is being eaten. If your piping is falling apart, we know it, and it shows up on there on a little, whatever, and tells you you better check it because you've got a problem. Now we have a filter. Nobody puts all this stuff together along with a copper silver ionizer naturally and a scale control unit and the unit that tells if you have any degradation of your piping. Yeah, we just do it all, and that's just in the boilerplex unit itself. But I've heard that a few times where customers have mentioned to me, well, I've seen other people that have done that, and I just show them a brochure. Say, hey, you tell me, you read the brochure, you tell me if anybody has ever done what we do, because we do it all. There's nothing left, we do the whole thing.
Well, I get this comment. One comment was that uh, copper silver ionization is a chemical. Where we state we use non-chemical means of disinfection, they stated, well, copper silver is a chemical. And if I understand this correctly, we're a mineral based. When
It's an
you
element. That's
positive,
exactly right.
go ahead.
Yeah, it's an element. It's not a chemical. It's an element. You
Perfect.
know, there's, yeah, there's only in the periodic table, I think there's 118 elements. They're not called chemicals because they're not chemicals. They are elements. So that's the difference from what we do and what everybody else does. This isn't something that that's like a liquid, basically, although the element that we use, the ionic copper, that's the difference. this copper is in ions. It's not in particles. It's in an ion. And that ion is so much different than a chemical. You can drink it. It won't hurt you a bit. And we have that numerous installations in swimming pools where people will obviously drink the water. Not necessarily a good idea, but people do. Hospitals, it's used for drinking water. It's totally harmless. Kind of interesting thing about that element is you can look this up yourself and show it to people. And but copper is, I think, the only element that your body, if it gets too much of, it rejects it. It doesn't hurt you a bit. You'll never know it, but it does not. It never acts like a poison. Basically, body just sends it back out again. But we have a lot of, yeah, we do that for hospitals, nursing homes, schools, a lot of schools. But where we use that unit for either boilerplex or hydroplex for potable water. And there's several of them like that, lots of them like that.
Well, and that's a great response, and it's so clearly not a chemical. And I'd like to make draw one more distinction, and that is that chemical biocides are toxic to humans.
Oh yeah.
Toxic to the guys that have to handle them, in the guys that maintain the cooling towers or any of the systems. Those biocides are highly toxic to humans, and you cannot use biocides when you're talking about domestic hot water distribution systems.
That's correct. Well, we have, what I tell people is, go get your label, go get your bucket of chemicals that you're dumping in your boilerplex. You will not believe what it says. It says a lot of them are, number one, they're flammable, they'll explode. Don't touch them. Don't get them in your eyes. They give a whole litany of things that anybody that reads these things is going. I'll tell you, I've had this happen. People have read that label. They have called the chemical company and says, "I don't know what you're giving me, but get that shit out of here and don't ever bring it back." Right. Because all they got to do is read the label. It's incredible. The crap that people, it says right on it, it'll blind you. You get it in your eyes, you can't see anymore. If you get it in the throat, it's pathetic, really. Every time, the first time I read one of those things, I was a little bit scared, And what scared me more than anything else is, like an idiot, I dumped some of this stuff for testing, but I didn't use gloves. This is hard to believe, but true. The next morning, I got up and fell over. I was dizzy. I was so dizzy, I wouldn't even drive my truck because I'd afraid I'd hurt somebody. It took 2 days for that stuff to go away. It was that bad. So, people are using stuff.
I've had the same thing where I reached into a cooling tower basin water to take a sample for testing, and it was being treated with biocides, and I got a little bit of a burn on the skin of my forearm. And sometimes, sorry, I'm a slow learner, but I won't do that again.
I don't do it either. I don't touch those chemicals without gloves. That's what I told people too. Is go ahead and take a look at the chemicals that you're using, and do you see anything in there that's good for you, non-toxic? With what we do for cooling towers for killing bacteria, including Legionella, of which I have all kinds of. Well, I think you have a Legionella from one of your customers, where you get a 100% kill. So read the label on your chemicals, and then, by the way, here's what we do with Legionella. And by the way, is what we do for Legionella. We put in potable water. You can drink it. I wouldn't recommend doing that with the chemicals you're using.
No, 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 that's for sure. Well, I also uh, uh, wanted to talk about um, a comment that was made that uh, magnetics have been around a long time and they don't do anything. That was a comment that was made to me by a consultant recently, and I just want to have your. I have an opinion about that, having operated hydroplex systems in this valley with the hardest water in the country for the last 7 years. But I wanted to hear your take on how would you reply to a statement like that, Tom?
Well, I don't disagree with them. Quite frankly, most of them do not work. And I have numerous engineering studies by engineering companies that were come in to find out if they were working. They were not. The difference between that and what we do is the way that we build those units, which is obviously preparatory. Proprietary. I'll get it yet.
You
But
got
at
it.
any rate, the way that the magnets are inside of that cylinder is what makes them work. You have alternating fields of energy. That's what does it. And the companies that I have worked with, I mean, these guys are from the university, say, yeah, that will work. That does work. We can prove it. And there's so many installations. Like one of the really good ones is NASA in Cleveland. You know, they called me up in a panic because they could not open up the plumbing, and they get fined every day because the job was not completed. They were stuck. They had nothing they could do. No chemicals, nothing would do it. They called me up in a panic, said, "Would your equipment, you know?" So the long story is, I'd have to go find out first. I'd have to take water samples and all that. So I went back and I said, yeah, it should work. You know, how long will it take to work? I don't know. We normally give people a month. I said, we don't have a month. We got to have it work quicker. I said, I honestly can't give you that information. All I can do, they bought it, by the way, is turn it on, have somebody in here, because once that stuff, the way that it works, physics, it breaks up, doesn't dissolve anything. It breaks up the molecules. The material that holds the molecules together is kind of basically on the magnetic end of things. I said, how long it'll take to do that, I don't know. So how long did it actually take? It took 1 day. And it took, I don't know how many filters they had to take that thing out, take a filter out. And these are big filters. You know, these filters are, oh, golly, what are they? Close to 48, 50, maybe 50 inches high and about, what would that be, 8 inches in diameter. They had to take out those filters several times a day because they were plugged up. And 2 days, basically, 2 days, they had full flow, still full flow now.
So that was a case, if I remember correctly, that was a boilerplex put on a closed loop, and they had some kind of a processed water. This was a vendor to NASA that had processed water. They had to, and the boilerplex was able to put everything into solution, allow it to move through the pipe, and then captured in filters. And once those bag filters filled up, you swapped them out with a new clean filter, and you did that repeatedly. And in a short period of time, they had clear water instead of kind of gunky black gunk water.
Yeah, it was exactly. That's not the only one we have done. That is my best application, but we have done basically that thing numerous times. And we've got another hospital here called Ravenna. Well, used to be called Ravenna Hospital. It's got a new name now. It doesn't matter. But we had the same problem there. We took 350 pounds of crap out of their water. They couldn't keep heat or cold, either one, because everything was plugged up. You're welcome to talk to these people. They'll tell you the same thing. And the people that are telling you they don't work, hey, go see them. Don't just talk about it. Let's play the trump card. You're telling me it don't work? I'll tell you what. Let's go see one. If it doesn't work, I'll pay. If it does work, well, you win. But at any rate, the hospital I was telling you about, Ravenna Hospital, we took 350 pounds of crap out of their loop water.
So that was a closed loop system that was being used for heating for a multi-story hospital?
Yeah, on and off. It could either be heat or cold. Doesn't matter. Depends on how they turned it on.
Right. So again, where other systems were ineffective on cleaning out their system, it's the magnetic core device that you install is what the effect that it placed on the water was what allowed the result to get all of this into solution and get it to move and get it basically to stop caking the walls of the pipe and be able to be caught in the filter and cleaned out. And that's pretty simple math, right?
That's exactly what happens. And again, the reason being is the effect of the magnetics on that alternating field. They take all those particles that are bonded together, they don't dissolve them, they just break them apart. And we see that, I've got so many cases that we've done the same thing. Right here in Ohio, there was another one, a big hospital, actually was converted into a nursing home. And I've got the water samples. I kept the water samples of pretty much everything that I've been telling you about so far. We got the samples of what we did. And same thing, we put the unit on, and a few days, that's an old hospital. Within a few days, it was wide open. Now, the downside of that is they had to change a lot of filter bags. And getting those filter bags out, it's not all that easy because those puppies, once they're full of junk like that, are heavy. So you got to have a way of getting them out of there. You got to hook it to something on a lever, and they're a bit of a pain in the butt. And we don't care. We don't care about fixing it. We're not worried about it as long as that thing does its job. And these people come to me just praising this, and they will probably be more than happy to talk to your people too.
That's great to hear.
Yeah.
That's great to hear.
Yeah, the accolades that we get for this equipment is unbelievable. It's amazing.
So the fact is that when we talk about the copper ionizer is for disinfectant, it's the control for bacteria, whether it's virus, bacteria, fungus, that copper, the positively charged copper ions deal with that. But this magnetic core device is what allows us to inhibit scale on the outside of the closed loop in the surfaces of the cooling tower, say, but also in a closed loop inside. Right. That magnetic effect on the water just allows things to go into solution that were previously caked in the water. It could be corrosion, it could be iron oxide, it could be whatever macrobiological stuff. Once it's in the solution, that's what allows it to be captured by a filter. So if you put only a filter on your closed loop, it won't be effective because you're not having the benefit of the magnetic core device to basically place things back into solution, maybe not into solution, but into movement inside the pipe so that they can be captured in the filter.
Yeah, exactly. It's just like grinding it up so it can move. I mean, grinding it up while it's in the pipe itself, it just starts breaking apart. Yeah, I've got photographs of that actually that show the before and after. And the after photographs, it looks like like ice crystals hanging from your. That's what they look like. Is they look like crystals hanging there, and that's what breaks them up. That's why they're all exposed, and now they can float and get out of the way. You catch them in a filter, you're good. You know, another thing about being able to do things like that is once you get that material in the pipes, you also have a corrosion problem because it actually, you know, that it literally eats the pipes, and either that or scales them, which is the other side of that. But even usually when you get scale, you also have corrosion. And I've got some things that I kept that we cut these pipes out of the customer, and it's amazing what's in there. You know, the pipe that started off at say 3/16 thick, it's about half that thick now, but there's layers of scale on that also, because the scale is also corrosive. So, and I'm not a scientist, so I can't tell you why. All I can tell you is the results. And what we see so often is verified by the customer. We've had numerous customers that have taken pictures, say, here's the fact, the guy from the, one of the hospitals I was telling you about, from taking pictures, and they would show me, this is what we had before, and it's gone, you know, just flushed down the drain, basically. But the advantages to what we're doing also has some other advantages. Another one of the hospitals in, this was in, I have to think about it for a while, but he called me up and said, we have a major Legionella problem. They're going to shut the hospital down in 10 days. All the people have to be vacated, doctors, patients, everything. Can you kill this stuff? Because the chemicals aren't working. So we fortunately had a unit on hand. All I had to do was take it up there, plumb it. They plumbed it in, not me. Take it up for them, showed them where to put it, turned the thing on, and I don't remember what organization was doing the testing. Um, I mean, it was, I think it was a government organization that did that. But at any rate, it's not really critical. But at any rate, we installed that thing, and 10 days afterwards, they ran another test, 100% kill. And it was so bad before we got there, they were going to shut the hospital down. We killed it all. I got the report on that.
Was that on a, I don't remember, was that on a um, uh, domestic hot water distribution line?
Yeah,
Or it was?
that's what it was.
So that hot water was coming out of the showers, the spray nozzles, the spas,
Correct.
the
Correct.
faucets, the kitchen sprayers, everything.
Everything. Legionella. It was pumping Legionella throughout the hospital. Yep.
Well, one of the comments that I received from recently was that that the systems, that copper ion, positively charged copper ion tech works very well in hospitals in those systems, but they said that if the system is not serviced regularly and properly, that it gets fouled and it won't work.
That's absolutely correct. What happens is it depends on where you are, where your water is. But what happens, the minerals that are in the water form scale, and that's what causes that problem. And then it traps the ions, is what it does, and they become ineffective. That's correct. So what do you do to fix it? Well, the best thing to do is pull the bar out. The bar is about, what would that be, 2 inches in diameter and 4 or 5 inches long. You pull the bar out and get yourself a pair of pliers and grind the bar and the pliers together, knock all that crap out, put it back in. If you take your time, this is what I kind of jokingly tell customers. If you take your time, you're not drinking coffee, you're not smoking a cigarette, it might take you 10 or 15 minutes.
Well, as I took a sip of my coffee there, the the for those that aren't familiar with it, the copper silver ionizer that is a component in the Hydroplex and the Boilerplex, it is a sacrificial. It employs a sacrificial copper bar.
That's exactly correct.
Sacrificial bar, by sacrificial, I mean that during the course of operations, 24/7, week after week, there's a residue left on that bar with the action of the ions leaving the bar and transferring from the anode to the cathode, and that anode gets residue on it, and that's what the guy's talking about when he says it gets fouled and then it doesn't work. But if you maintain it, if you just clean that off on a regular basis, which is any system has to be maintained, right? But if you clean that off on a regular basis, then it is 100% effective.
That's exactly right. It's like taking medicine for a pipe, you know. If you got a jar full of medicine and you don't take it, it's not going to do you any good if you don't get it in your system. And it's the same thing with what we're doing. If you allow that scale to form up, it inhibits the copper, and it's not going to work. That's absolutely true. Now, we looked at that also. We try to solve all the problems before they exist. So what do you do to prevent that from happening? We have a copper test kit. So you run the copper test, and if you're at 3 ppm, you're fine. If you're down to 1 ppm or half a GPM, clean the damn bar. So you know when the bar is dirty, and it's easy. Take it out and clean it. Problem solved. It's working again. Because that copper test, we also do a bacteria test. You know, so what's the level of bacteria that you have? If you have bacteria in your pipe, your level, if you have copper in the pipe, which is what we use, and the scale control unit, and you run these tests, you can run the test every day, all day if you want. You get none. You get no scale, you get no nothing except water. That's all you get in there. So the thing is, keep it clean. If you have hard water, which we have tested, some really nasty water for a couple of our customers, and the idea is keep the bar clean. Everything worked just fine. You don't have any bacteria. If you have copper, you don't have bacteria. That's what it levels down to. So test it. If you got a copper, show a copper positive test, you got to fix it. You got to clean the bar.
Well,
no, that's with electricity, you know. It's a 12 volts DC current.
Right.
That's what the DC current. You got the bars one polarity and the housing is another. Yeah.
So that's the ionizer. And but when you say, if we go back to the just briefly back to the magnetic core device, this is a device that we don't alternate the fields, but when we have alternating fields in the magnet, right? And then as the water passes through it, it's passing through alternating fields. These are permanently programmed ceramic magnets that, if I'm not mistaken, you said you have estimates that they're still almost 100% after 100 years.
Yeah, I think they rate them at 125 years. I think that's what it is. But I mean, they had to rate it someplace. Probably, depending on what you're doing with it, they're going to last a lot longer than that. And I tell people, if you put one in, you don't get 125 years out of it. I'll send you a new one. No problem.
That's confidence. Confidence in your longevity, right?
There you go.
Well, I really appreciate you taking the time here on a Saturday to talk, and this is really valuable. This Zoom call is going to wrap up here on its own without it's kind of out of my. We're going to have a hard stop, I should say, and I just want to say thanks not only for taking the time to talk about it, but for sticking it out year after year, decade after decade, trying to champion this cause of getting folks to stop using toxic
Yeah.
chemicals in their systems. You know, we have over 12,000 cooling towers alone just in the Phoenix Valley here.
Wow.
And that's and those biocides that are used predominantly, they escape the tower, whether you have an eliminator, whether you have anything, they just escape the tower into the environment. So you have 12,000 points of toxicity, and that includes schools, elementary schools, universities, hospitals. I mean, this just seems like we can do it better.
Much better, much safer. Yeah, we've installed in a couple of places where the cooling tower would be like on the roof of a garage, low garage, and right beside the cooling tower would be a walkway. People walking through there, kids, and I've told a couple of them, I said, boy, if somebody goes through there and they end up blind, a kid, you guys are gonna have a problem. So just move something, get it out of the way. That stuff is not good for getting into people or on their eyes or anything like that. It's there's better ways of doing it. And why even any places do it the wrong way? You think somebody's not paying attention. How could anybody do that? Stop me if you've heard this. You may have heard this, but I was in I think it was DC or Baltimore. It doesn't matter. But the guy up there, the maintenance guy, was sharp. He knew what he was doing. So yeah, I think it was DC, but it was hot. We're on a roof, tar roof. I mean, the heat was coming off that thing like crazy. I think I had 4 or 5 people from the post office too was up there to see this unit, and the guy. He was great. He took them around. We were up on the roof. He was showing them, opened up the doors. It was one of these cooling towers where the doors are maybe 3, 4 feet, probably 4 feet tall. They weren't, full size. But at any rate, so he's showing them this, and the tower basement was perfectly clear because we had sweeper jets in there. So he gets all finished up. The doors are open to the cooling tower. And again, it is incredibly hot. And he's asking people, I said, any more questions? Everybody okay? What we're doing? And they were happy. He said, yeah, okay. So he turns around with the door open, gets a handful of water and throws it on his face. It was that hot. Washes his, and everybody, I thought they were going to fall off the roof. They were literally backing up, with eyes that big. So the Kodak moment was when he looked up and saw all these people terrified. He looked, what? So what's wrong? What are you looking at that I'm not seeing, type of thing? He was washing his face in cooling tower water. Eyes didn't hurt a bit.
The point is being that had he done that with a chemical system, he'd have been suffering. He never would have done that with a chemical system, but with a Hydroplex, with just copper, magnetically treated water and copper in there, he is perfectly safe in doing that. We have a fella that goes in and services one of the towers that we have an installation on, and here in Phoenix, it can easily be 110, 120. And he just gets down to his shorts and climbs right through the open screen and gets in there and starts sweeping out the corners. And he just, it's benign. I like this word, benign. This positively charged copper ions is 100% effective, where the chemicals are not 100% effective. Nope. And yet the copper is 100% effective, and it's benign. It's almost contradictory. It's ironic but anyway, this is a great argument to move. And I'm sorry, we're going to have to sign off here. I'm going to stop the recording. I want to spend one more minute with you before we hang up. I'm going to stop the recording. So hang loose just a second here, Tom. Thanks again. It's really great. We're going to do this again soon.
It's always a pleasure. Thank you.
Okay.